the last digit to be made. This is all about 0. With 0, 1490. Without MCDXC. Do you understand 0? Let's find out all about what I'm talking about and more in this episode. It's board time, and by the end of these boards, you'll know about nothing. The history of 0. Number systems without 0. Most early number systems without 0 used a symbol for 1, a symbol for 10, a symbol for 50, and so on. And they didn't use place value, as in multiplication. They used addition. To write 3, you would write the symbol for 1 3 times over. Some later number systems, like Roman numerals, wrote numbers like 9 by putting an I in front of an X. An I is 1 and an X is 10, so that's 9, because you subtract the 1 from the 10. That's called subtractive notation. To write 11, you would write the I behind the X, XI. You add it together, or additive notation. And here you have a clock with Roman numeral numbers on it. The invention of 0. 0 had been around as the idea of nothing and as a quantity for many thousands of years. But the symbol and main idea of 0 and using it in mathematics only came around 1500 years ago. The Indian astronomer Brahmagupta in the 7th century defined 0 as subtracting a number from itself. 5 minus 5 is 0. And many call him the inventor of 0. I personally disagree with that, thinking that he just defines 0. The complexity of 0. Why is 0 so hard to understand? 0 is hard to understand because counting numbers like 1, 2, 3 correspond to real things. For example, you can visualize 1 as 1 cake, 2 as 2 cakes, 3 as 3 cakes. But you can't really visualize a not cake or 0 cakes. So here, this is 1 cake, and this blank is 0 cakes. The scientist Andreas Nieder says that there are 4 steps of understanding 0. First step is recognizing a stimulus. So, can you see a pen in my hand? If you answered yes, then you can do that. Recognizing the difference between nothing and something and being able to respond to a lack of stimulus. So, do I have a pen in my hand? And has the pen disappeared? If you answered yes and yes, then you can do it. 3. Recognizing that 0 is less than 1. This is where small children fail. So, you can see here I have 3 boards and here I have an empty. So now visualize that there are no boards on it. Are there less boards on it or more? If you answered yes, then you can move on to the 4th stage. So what is 5 minus 0? 5 minus 0 is 5. If you wanna, there's a challenge. What's 5 times 0? It's 0. And if you really wanna, what's 5 divided by 0? The answer is undefined. I'm not joking, it's undefined. And there are many other uses, but those are like complicated math and stuff, and we don't need to. So bees can understand stage 3. When trained bees were shown cards, and they were trained to pick the lower number with some sugar water whenever they picked it. When they were shown 0 and 1, this shows 2, they picked 0. The importance of 0. No 0 can be confusing. Some number systems used to use a space instead of 0. For example, this is a number. If a spy sent a message to the warrior's camp and it said, there are 1, some number of spaces, 2, some number of spaces, enemies coming. Is that number 102? Is it 10,200? Is it this humongous number? It's actually 10,020 in this example. So big numbers would make no sense without 0. Using 0 as a placeholder makes numbers much less confusing. It's like using multiplication instead of addition. It's easier to do 5 times, it's less confusing to do 5 times 3 than 3 plus 3 plus 3 plus 3 plus 3. And those are only the small ones. So this is 10,249 in the number system we use now, and this is it in Roman numerals. M, C, C, X, L, I, X. It looks super confusing. They both represent the same quantity, except one uses 0 as a placeholder and it uses multiplication and place value, and the other doesn't. Manipulating numbers. Without 0 as a placeholder, calculations make no sense. For example, which is easier? XLIV plus CMLXIX, or 44 plus 969. If you have 44 plus 969, you can line it up and do an addition, right? But when you have XLIV plus CMLXIX, there's no such thing as place value. You can have a number with one digit, M, which is 1,000, is much larger than this number, XIX, which is just like 19, and it has more digits than 1,000, so that makes no sense. You have to do it in your head and then, figure out how to translate it. They're both actually the same, and they both add up to 1,013, or in Roman numerals, MXIII. And now it's playtime. It's playtime, and today we're going to be attempting to do 1,490 plus 10 without using 0. First, let me write it in decimal and what we're using right now. (1,490 plus 10). And then I'm not going to write the answer, even though by now you should know what it is. Now I'm going to write it in Roman numerals. So, what is 1,490? So, 1,000 is M. 400 is 1 less than 500. So, 100 less than 500. So, CD. And then 90 is 10 less than 100. X, C, plus, and then what's 10? 10 is X is equal to, and we're leaving it blank. And now I'm going to use it using blocks. So 1,000, 400, 3, 4, 400, and 90, which is 9 tens. And 9. And I drew one a bit too large. Imagine that this is smaller. And so that's 1,490 plus 10 is equal to, now I'm going to use counting rod numerals, which I don't remember. I'm going to look on my computer, and here, rod numerals. So 1,000, and then 400, 1,400, and then I need a 9 for my 90. So that's my 90, then 0. Well, this is a 0, but in the earlier counting rods, there was no 0. Using a blank space here, plus, and then 10, which would be and then blank space is equal to now. So here, this system uses place value, and it goes horizontal, vertical, horizontal, vertical. So horizontal 1000, vertical 400, horizontal 99, which is 90 because place value, then vertical blank space, which is just blank space, plus horizontal 1 for the 10, and then a blank space is equal to So now I'm going to solve it. $1,500. I suppose we should put commas. And so this is just, and this I'm not sure I'll have space, so I'm just going to erase this. So now I'm just gonna write 1,000, 1, 2, 3, 4, 5, 1,500. And now in counting rods, the answer is 1,000, and then, wait, so 1,000, 5, then blank space. I'm just gonna put a line here. It means nothing, but it's just to signify the end of the number. You have 2 blank spaces here. It's 10 under 10. There are 4 stages of understanding 0. 0 was defined around 650 AD. 0 helps manipulate numbers. 0 is a place value placeholder, and it helps simplify numbers. Modern number systems use multiplication place value instead of addition. 0 makes numbers look less confusing. Even bees can understand 0 to a certain level. Some early number systems were so confusing, even the scribes made mistakes. Like on Roman numerals, there's this stone where it's supposed to say some number, I can't remember which number, and the scribe actually made a mistake. And the symbol for 0 is not the same as a capital O anymore. It's actually thinner, if you see here. And 0 is probably the most important digit. It's magic resources time. And so the first book that we have is the Book of Numbers. It's a great book, even when you're not looking for it as a resource. It details more about numbers than anyone could ever think about. It's got the romance of numbers all the way to the primacy of primes. And it explains very complicated things in a simple-ish style. Recommended for slightly older watchers. And the second book is Everything You Need to Ace Math. This is the second one of this series that I've had. I once had the Everything You Need to Ace Science, and this is the math. And this one is for a younger watcher. It's super organized. It explains tough topics. And so basically, you'll enjoy reading even if you don't like nonfiction. It's the end of another episode. Please subscribe and hit the notifications bell if possible. And here's a joke to leave you on a happy note. So, what did people say to the inventor of zero? Brahmagupta. Thanks for nothing. And don't forget, there's always more information in the description below. And remember, you are never too young to excel.